So what we're going to be looking at is we're going to be looking at how do you use secant lines to find the slope of tangent lines. And this is one of those skills where what we want to do is we just want to utilize the slopes of the secant lines in order to estimate the actual slope of the tangent line. Later on, we're going to see how it is that we can use this process in order to actually find the actual slope of the tangent line. So what we're going to start out with is let's start out with like kind of defining what both the secant line is and the tangent line. So a tangent line is a line that intersects a curve at one point. And a secant line is a line that is drawn through a curve at exactly 2 points. So if we take as an example, okay, let's say for example, I've got this graph here, okay. The tangent line, we'll say, is this line right here, okay. It's a straight line. It intersects the curve at exactly 1 point. Okay, so here's your tangent line. And let's say you take this point here and you take this point right here, okay. We draw a line through those 2 points on the graph or on the curve. And what we get here is that's a secant line. Okay. Now, when we talk about a tangent line, we define a tangent line. Okay, it's defined at a particular point. A secant line is defined at 2 points. Before we talk about tangent lines, which are kind of the more difficult idea than secant lines, let's first talk about how do we actually find, say, for example, the slope of a secant line. Because for us, that's going to be the thing that we really care about. Okay, so we'll start out with this idea of finding the slope of a secant line. Okay, now a secant line is defined at 2 points, right? So we are given 2 points on the curve. And let's take, for example, that we use f of x equals x squared. All right, just as our example. And suppose we want to find the secant line, find the slope of the secant line at x equals 2, or between x equals 2 and x equals 3. And x equals 3. Okay, so what we're going to need to do is we're going to need to actually figure out, okay, where those points are, right? And then we're going to have to relate them to slope. But actually, maybe what we should do is we should just relate them to slope first, all right? So our slope, if you remember from algebra, which you must remember from algebra, is going to be the change in y over the change in x, okay? The rise over the run. This is another way we can think about this is the change in f of x, because that's the function over the change in x, okay? And for our purposes, right, in our example, that's going to be f of 3 minus f of 2, okay, because we'll evaluate the graph at those 2 particular points divided by 3 minus 2. So f of 3 is going to be 3 squared, because our function is x squared, minus 2 squared, and we'll divide that by 3 minus 2. So that's going to give me 9 minus 4 over 1, which equals 5. Okay, so that's the slope of the secant line. Okay, the slope of the secant line. What we'll do is we'll evaluate the value for the function at each one of the points for the secant line, okay? And that's our rise, that's our delta y, okay? And we'll divide that by our change in x, right? Which in this case is 3 minus 2. So let's take a look at this graph. So there's x squared, okay? And let's say, for example, this is x is 2, right? So what we see is somewhere here, this should be like 4, okay? So that's f of 2, okay? This is kind of a key idea. So that's f of 2 right there, and that's x equals 2, and we know f of 2 equals 4. So this point right here is 2, 4. Then we go over to 3. Perhaps we ought to draw a curve a little bit better. 3, okay, is up here, and here's f of 3, and it's going to be at 9. So this is 3, 9, right? And then we just draw our secant line. Okay, it's got a slope of 5, and so our secant line goes through those 2 points and looks like that. Okay, not the best line in the entire world, but that's basically the idea, right? Okay, we have figured out what the value is for f at 3. Okay, it's 9. Okay, we figured out the value of f at 2, and that's 4. We drew a line between the two, and the slope, right? The slope m is going to end up equaling 9 minus 4 over 3 minus 2, which equals 5. And that's the slope of that secant line. Okay? That's the idea. Now what we're going to do, I'm going to kind of zoom in on this problem. Okay? And, okay, you know, this goes here, this guy goes here. Okay. All right? And so now what we can see here is basically this is f of x equals x squared. And we've zoomed in, and what we zoomed in on is we zoomed in on the line between 1 and 2, or 0 and 2. Okay, so here's x equals 0, x equals 1, x equals 2. So one of the cheap problems that I'm going to try and solve is I'm going to try and solve this question of, right, what's the slope of this line here? The slope of this tangent line right here. And I'm going to draw that in red. Okay. Okay. The problem is that I don't actually know what that slope of the tangent line is. I might actually be able to like kind of go, okay, well, if I take this, there's 1, right? It starts right there. We'll go over to 2, okay? And then I'm going to try and see, okay, so right about there, well, is it 2 over 1? Is it 3 over 1? Is it 2.5 over 1? I don't really actually know. And that's actually a big problem. That's a big problem that the people who were inventing calculus had. They wanted to know, you know, what exactly was the slope of that tangent line for a lot of different reasons, but they didn't have a way to actually figure it out. They didn't want to estimate. That's a guess. That's not how mathematicians work. Okay? So what they started to do is they started to think about it in terms of these secant lines. So let's take an example. Okay? Let's take an example of the secant line between 1 and 1.5. Now the secant line between 1 and 1.5, okay, it looks kind of like this. Yeah. All right. Now it pretty closely approximates what it is between 1 and 1.5, but it's not exactly there. Okay, it's not exactly that tangent line. Okay. Now what happens? So like we'll mark that one here, and it's going to be kind of greenish. what happens if I move it in closer? Okay, so now I'm going to move it in closer. Say, for example, I move to 1.25, and now I draw a tangent line between 1 and 1.25. Okay, and what you'll notice here, what's kind of even hard to even see, okay, especially at the top there, is the fact that those tangent lines, that tangent line is going to start to look an awful lot like, that secant line is going to start to look an awful lot like the tangent line. Okay, we kind of draw that out, and we're like, oh, wow, that's getting close. Now let's imagine that you get even closer. Now, right, okay, that slope of that secant line, it's pretty much right on top of the slope of the tangent line. Okay? Right? It's not the exact same line, but like they're basically going in the same direction. That's what it means to have the slope be the same. Okay? We should actually even say that. Slope being the same means the two lines are going in the same direction. And the cool thing is that as the points that we draw the secant line on, so like we've got 2 points, right? One is 1.5, because that's the one we're trying to figure out the tangent line on. And the other one is some other point, okay? But as we get, that other point gets closer and closer and closer to 1.5, the tangent line and the secant line start to look an awful lot alike. They end up being in basically the same direction, right? So as x gets closer to 1.5, the tangent line and the secant line start to look the same. And this is what those gentlemen found, okay? They found that, in fact, that was exactly what was happening, right? That as the 2 points got closer to one another on the secant line, they began to approximate the tangent line, which is it's amazing, right? We're going to actually prove this later on inside of the class, but for right now, we're going to take this idea and we're going to see how is it going to help us to find the slope of the tangent line. So I'm going to construct a table. Okay? And what I'm going to do here is grab these, make a couple points. Okay? And we'll start out with x equals 1.5, okay, is where we want is our tangent line point. So f of 1.5, which is that point at 1.5, is going to equal 1.5 squared, which equals 2.25. Okay? So that's always going to be like, that's going to be our bigger point. That's going to be our x2. So our x2, our x1, x2, y2, our x2, y2 is going to equal 1.5, comma 2.25. So now let's take a look at what happens to the slope of the secant line as we approach 1.5. Okay, as we get closer and closer and closer to 1.5. All right, I'm going to start out at 1.0. Pretty far away, that's where we started. Then I'll go to 1.25. Then I'll go to 1.4. Okay, so now I'm getting closer. Then I'll go to 1.45, getting even closer. 1.49, 1.499, and then 1.4999. Okay? So that's x. Here's f of x. Okay? So that's going to be 1 squared. That's just 1. 1.25 squared is going to be 1.5625. 1.4 squared is 1.96. 1.45 squared is 2.1025. So that we're clear, that's x squared. 1.49 is 2.2201. 1.499 squared is 2.24701. Okay, and then 1.4999 squared is going to be 2.2497001. Lots of zeros on that one. Okay, notice that these two are going to be pretty close together. That makes sense because they actually are really close together. They're 9 1,000ths or 9 10,000ths off of one another. So that's really close. So now let's find the slope of the secant line. Okay, so this is going to be 1, or actually it's going to be 2.25 divided by 1.5, or excuse me, 2.25 minus 1 divided by 1.5 minus 1. And so that ends up giving me 1.25, okay, over 0.5, which equals 2.5. So the slope of that secant line is going to be 2.5. Myself a little bit more room here. Next up, we're going to have 2.25, right? Okay, again, that's f of 1.5 minus 1.5625, and then that'll be divided by 1.5 minus 1.25, and that equals 2.75. Then I'll take 2.25 minus 1.96, and I'll divide that by 1.5 minus 1.4, and that'll equal 2.9. Then what I'm going to do is I'll take, right, 2.25 minus 2.1025 divided by 1.5 minus 1.45, which equals, this will give me 2.95. If I do the same thing with 1.49, what I'm going to get is I'm going to get then 2.99. With 1.499, I'm going to get 2.999. And with 1.4999, I'm going to get 2.9999. Okay? The big thing to get about this, right, and the reason why we go out and do this is to see, you know, what's happening to this slope, right? What's happening to the slope? The slope of the secant line is increasing. That's one thing to see, okay? But more importantly is to see that not only is it increasing, but it's increasing towards a particular point, right? Okay, so the slope increases or approaches, the slope approaches 3. You can kind of see that, like it's getting closer and closer. As we get closer and closer and closer, as x gets closer and closer and closer to 1.5, the slope is getting closer and closer and closer to 3. Okay? And so our estimate for the tangent line is 3. Our estimate for the slope of the tangent line, excuse me. So that's our estimate for the slope of the tangent line. So basically what we've seen graphically is we saw that the secant line starts to look like the tangent line as we get closer, as x gets closer and closer and closer to the point that we want the tangent line at. And what we see on this table is we see the same thing. What we see is that as we get closer and closer and closer and closer and closer to the point that we want to find the tangent line at, our slope gets closer and closer and closer to that slope of the tangent line, right? We're going to prove this mathematically, but we want to kind of just get that idea, right? What happens as x gets closer and closer and closer to 1.5? What happens to the slope of that tangent line? Okay? And in this case, we say, oh, it looks like it gets closer and closer to 3. All right? So that's how we go about actually approximating the slope of the tangent line using the secant line. Okay? What we'll do is we'll take a series of secant lines, okay? And what we'll do is we'll find the slopes of each one of them as they get closer and closer to the tangent line. And as they get closer to the tangent line, it'll start to become basically the slope of the tangent line. All right? That's the idea. Now, in this case, I did 1, 2, 3, 4, 5, 6, 7. 7 different choices, and it gave me a very clear idea of what's happening to that slope. All right? Between 6 and 8 is probably a good number to do, and make sure that you get, some different values, right? So we got one that was like 0.5 away from the value that we were looking for, and then we got all the way up to 1/1000th. Okay, 1/1000th of excuse me, that's 1/10,000th away from the point that we're looking for on the tangent line. All right, so those are just some good numbers to put in there. Okay, picked an x, found f of x for each one of those, and then found the slope of those secant lines, and then saw what happens as x approaches the point of our tangency. Okay, and that concludes the lecture. All right, that concludes this particular section.